All right, so we looked at many-to-many. Let's look at something simpler like one-to-many. We're, for instance, implementing faculty having a one-to-many relationship with courses, or faculty having a one-to-many relationship with section. Okay. Now here too, you have several options. Now the classical way of implementing one-to-many is to have a child, right, reference the parent. Right, that's a classical way of having in relational databases, right? You have the children having a foreign key back to the parent's primary key. Yes? And in a database, you can actually implement it in two ways. Either as a foreign key back to the parent key, or a mapping table. A mapping table would be an overkill, right? A mapping table allows you to do a many-to-many, where one-to-many is a subset of a many-to-many, right? But nevertheless, it's an option. But typically, the way we do one-to-many is just to have a foreign key back to the primary key. This is what we have here. A section knows about the faculty who's teaching that section. And here we have a course keeping track of who authored that course. Yes? Kind of like a foreign key back to its parent. Alternatively, right, we could have the other way around. Instead of the children knowing about the parent, we could do it the other way around. We could have the parent faculty having an array of all the children, right? Where you have the IDs of all the children all the child sections that the faculty is teaching, or the faculty knows about all the courses that they have authored listed here. Okay. These are very similar to what we've done in the previous many-to-many. Right? But there's a third option, which is even more interesting. I don't know if you can see that down there. No, I can't do that. I guess there's no way of getting my way out of the. Oh, there we go. So the other option is not to store only the keys, right? Not to store only the primary key. So this would allow me to then do a fetch, right, and retrieve that section whose ID is that ID. But there's another more interesting way of doing it, is that you actually store the object itself in the array. See that? Right? And this is actually the preferred way of doing things in Mongo. This is what Mongo encourages to do, is that the object that are children to a parent object would actually be embedded inside of the parent. Right? This is an array. Then the JSON that represents that section would live in here. Section 1, Section 2, Section 3 would live here. Yes? So that's a preferred way of doing it. Right? But you have to consider the use cases. Remember, use cases always will drive the actual implementation. Right? The problem with this implementation is that you might want to use the instance of Section 1 outside of this array. Okay, maybe you want to list all the sections. Right? If the sections live in the arrays of sections of each faculty, it would be very inconvenient to retrieve all the sections, because I would first have to iterate over all the faculty to fetch then all the sections, right? It would be very, very inconvenient. So depending on what the use cases are for the sections, you would either implement it this way, right? Or you would implement it as IDs, as primary keys. Right? So if you need to be able to manipulate the sections all by themselves without having to, without the context of the faculty, right, then it's better to have the sections implemented as separate collections, and then we have references to those sections. If instead you have objects that make no sense out of the context of their parents, then this would be the preferred way of doing it. So let's look at a couple examples. For instance, in the example of topics, lessons, and modules, right? Do they make sense to exist outside of the context of a course? For instance, a course has several modules. A module might contain multiple lessons. Multiple lessons contain multiple topics. Multiple topics contain multiple widgets. Yes? Right? would there be a query where I want to list all the widgets across all pages, across all modules, across all courses? It would make no sense, right? It would make no sense that I would want to do a query like that. So in that sense, a widget might make perfect sense. A widget would be embedded inside of its parent topic, or that a topic would be embedded inside of its parent lesson, or that a lesson would be embedded inside of its parent module. And maybe module would be embedded inside of its course, right? But a course embedded inside of the author of that course, that would probably make no sense. Okay, so all the embedded objects, right, would not have their own collections, would not have their own tables, but would be embedded as objects inside. But the course would not be embedded inside of any faculty or any section and whatnot. Make sense? Right, on how you would implement it. And the clues would be given by these diamonds here. Right? These diamonds tell you that there is no life cycle dependency between these two. Right? That's an aggregation, right? It says that if I remove the faculty, the course is still there. Right? I should be able to manipulate the course without the existence of a faculty. Right? I should be able to, a section should exist without the necessity of somebody actually teaching it. Right? At some point, I'll decide who teaches it, right? But a faculty's come and go. But the section still remains. Make sense? Right? But if I have here a course made up of multiple modules and multiple lessons and topics and whatnot, if you remember when we implemented that, we used the composition, right? It was filled in diamond, right? So now the dependency, the life cycle dependency existed. So if I remove the course, it would remove all the modules. It would cascade down to removal. Yes? It would make no sense for them to exist outside of the context of their parent. Make sense? Right? So in that case, though, they would be embedded objects. Right? Excellent. Right. So the oops, why is this? All right, there we go. So the classical way to implement it would be to section have a foreign key back to the parent, something like this, where the section would have a reference, right, to the ID or foreign key of the faculty who's teaching that section. Or you would implement it as embedded objects, right? Embedded objects, where you would have here course having modules, modules having lessons, lessons having topic. Notice that we're doing composition instead of aggregation. See that? So that's a clue. That's a clue that these guys, these topics, these lessons, these modules, have no meaning outside of the parent relationship. Right? That if I remove the parent, all their children are gone as well. Right? So they can be embedded in their parent, so that if they're removed, the children are removed as well. Right, so they're embedded inside of another. You have the outer course, multiple courses, then a course having multiple modules, each module having multiple lessons, each lesson having multiple topics, and so on and so forth. So if you remove the course, everything is gone. Yes? Right, so you have something like this. You have two topic objects. Lesson 1's topics is an array of those objects. And then the lesson in a module, the lessons of a module would contain multiple lessons. And then the course modules would have multiple modules, right? Each one being object instances. The implementation might look something like this. Here's modules. Here I'm inserting a brand new module. And you'll notice here that one of the fields is a lessons object. Notice that the lessons object is an array of an embedded JSON object. See that? It's an embedded JSON object inside of the parent object. When you insert it and you print it, it's a field that contains an array of objects. So this is an embedded object. Pretty cool. And you can insert another lesson. Here we've inserted yet another lesson. Notice we're doing push a brand new lessons, right? Name lesson 2. So now we have 2 lessons, right? Embedded inside of the parent module. Okay, pretty cool. We can keep embedding. Let's see. We can. Oh, yeah. We can retrieve. Okay. So once you notice that this could be arbitrarily nested, right? It could be fairly complex. So ideally, you would want to be able to traverse this data structure, right? And if you're gonna if you're gonna retrieve something and you're gonna pattern match, obviously you can pattern match these top level fields. I want a module whose name is module 1. We've done that already, right? But because now you have these nested structures, these queries of these finders could get pretty complex. So I don't just want a module who has name module 1. I want a module who has a lesson whose name is lesson 2. Give me all the modules whose lesson have a particular lesson. So that's much more complex, right? Because I have to go down, it would have to go inside, navigate, iterate over all the children until it finds a particular pattern matching, right? So that would be much more complex. Nevertheless, Mongo supports that, right? For instance, you could say, this one says, find me the module who has module 1. Well, we know that already. So this is retrieving. And also notice I only want the lessons. I don't want anything else. I don't want the name. I don't want anything else. So here's the lessons. So it retrieves the ID and the lessons. But you can before we get on the query, let's insert something even further in, or something much further. So for instance, here we have lessons, and we have lesson 1, we have lesson 2. We can insert into the lesson, insert a whole bunch of topics instead of the lesson, right? So now this gets a little weird because somehow I need to be able to identify that it's this one that I want to insert and not that one. Okay, but I want to insert into topics that doesn't exist just yet and insert into lesson 1. So there it is. So here's a module. I want to modify module 1, right? Module 1, comma. So 2 criteria, 2 predicates. I want the module whose module 1 is module 1 plus. I want to find a lesson whose name is lesson 1. Notice that it allows me to navigate and say lessons.name. Lessons.name. And lessons.name, notice that name appears in multiple instances of lessons embedded here. Right, so this lessons.name is actually a for loop. Right? Find me the instance embedded in this array that matches the name with lesson 1. Notice lessons.name. Find me. I don't know which one. It might be the 3rd element in that array. I don't know which one. Yes? The context of which of that embedded object was found, say it was on index number 3. Here was index 0, right? The first one. It found it in the first one. That context is followed into the update clause. So for instance, now that I know it's index number 3 or 4 or whatever, right? There is a position operator. The position operator is wherever you found it. I don't know where you found it, right? In the 3rd spot. This says, okay, well now that you found the element, I want you to modify the top. I want to modify the lessons at position wherever you found it, position 3 or 4 or 5. I want to add a topics that has an initial value of this array of topic with a name topic 1, which basically inserts this topic in there, right? It has an array of that object. Pretty cool, right? That you can now navigate complex structures of objects that you stored in there. This idea has a limitation. At least in the version of Mongo that I was using. And so let's illustrate that limitation of these dollar signs. These are called positional operators, right? Positional operators. And the limitation is that you can consider this to be arbitrarily nested, right? Objects that contain objects that contain objects that contain arrays and whatnot. So the dollar sign only works so deep. It can't arbitrarily nest forever, right? It can only go so many levels deep. And so let's talk about that.